The atrial volume receptors are the other receptors I want to talk about a little bit. There are actually two types of these. The type A respond to pressure, and the type B respond to stretch. So you'll notice that during A, this increase in pressure happens when the atria contract. So I'm not exactly stretching my atrial wall during that time, but I'm increasing the pressure on it because I'm contracting it. Your type A pick up that increase in pressure, and the higher the pressure, the more action potentials it sends out to your medulla. Okay? So these volume receptors send out more action potentials the higher the pressure is in the atria and the great veins. Okay? The type B respond to stretch. So here's what's happening here. Your atrial contraction is over. Here's your ECG. Your ventricular contraction starts, and your mitral valve closes. Okay? And your mitral valve and your tricuspid valve have closed, and during the time that they're closed, blood accumulates in your atrium. And it's kind of like accumulating up against that closed valve. And as it accumulates, it stretches the wall of the atria. Once you get enough in there, it starts to stretch it out. And as it stretches out the walls, the type B fire. And the more stretch you get, the more impulses are sent to the brain. Okay? So if we look at relative impulse frequency and we look at relative change in blood volume, you can see the impulse frequency goes up as blood volume goes up. Okay? These responses are hooked up to your kidneys. So your medulla, when it gets impulses from your volume receptors, it sends output to your kidneys, and this is the way that happens. Your volume receptors, if you get a decreased pressure and a decreased stretch, you get decreased firing, and that causes your hypothalamus to kick in. Your hypothalamus secretes a hormone called antidiuretic hormone. Dr. Phil will talk about this a lot. Okay? I'm not going to talk about it a lot, but what I am going to tell you is that ADH increases water reabsorption in the kidney. That means water is reabsorbed from the tubules after you filter your plasma, and it's retained in the body. And you retain more water, and your blood volume goes up. And you'll also note our baroreceptors are also involved in the responses in the kidney. Okay. Here we have our responses going to the medulla, and the medulla causes the increase in sympathetic output and decrease in parasympathetic output, and you get a baroreceptor reflex. That increased sympathetic activity stimulates the kidneys to secrete renin into the plasma. Okay. And then that causes the adrenal cortex to secrete aldosterone, another hormone that you were going to hear about a lot in GU, and not a lot here other than the fact that you should know what the net response is and that they're involved. The net response is water reabsorption. We won't worry about the mechanisms behind that right now. They're detailed, and you have to really understand how the kidney works first. Okay? But you get net water reabsorption and an increase in blood volume. So blood volume is regulated long-term in the kidneys, somewhat due to the increase in sympathetic activity from the medulla, and somewhat due to the fact that your volume receptors are less active, and you get ADH secretion from the hypothalamus. Okay? Both of these tend to increase blood volume, increase water reabsorption, increase blood volume. Okay? We have a variety of other reflexes that I give short shrift to. Every once in a while they'll pop up on USMLEs, but they're never covered in detail. The Bainbridge reflex is a response. You get an increase in heart rate when your atrial volume increases. So you might think of this as being a response to an increased central venous pressure, the implication being that you're in heart failure. So if the pressure, CVP, goes up, your body might think, oh, he's in heart failure, and then increase the heart rate in response, okay, to try to help out maintenance of mean arterial pressure. It's more important in animals, not very important in man, but it's there in man, okay? We don't talk about it a lot. The chemoreceptor reflex, we talk about a lot, but we do it in respiratory, not so much here. But I want to introduce it here. You have chemoreceptors in your carotids. They detect oxygen. And when you have decreased arterial oxygen, your receptors initiate a respiratory response. You breathe deeper and more frequently. And there is a secondary cardiovascular reflex. That is, you get vasoconstriction and increased heart rate. And the idea is to increase mean arterial pressure and try to increase perfusion of the tissues that need oxygen, okay? So it can enhance delivery of oxygen and increase flow to important tissues like the brain and heart, where you get a fairly big drop in oxygen content in the blood. By increasing mean arterial pressure, you increase tissue perfusion. So the increased tissue perfusion gets you more oxygen in. The arterial blood isn't as oxygen rich, but you're delivering more by increasing the flow, okay? The Cushing reflex, or the CNS ischemic response, is a really odd one. If your mean arterial pressure really drops a lot, like 50 millimeters of mercury, which is way low, okay? Or you increase cranial pressure, let's say because you have, a lesion there, then you get this huge, massive sympathetic outflow, which increases TPR. And the idea is your body says, this is an emergency, right? Mean arterial pressure has really dropped. We got to do something drastic. And that drastic thing that you do is you get this massive sympathetic outflow, and you sacrifice almost everything to get mean arterial pressure up and maintain perfusion of your brain, okay? So it's this massive sympathetic outflow that's a last-ditch attempt to keep the mean arterial pressure high and keep your brain oxygenated. The reason why the lesion does the same, the reason why it makes sense, the increased MAP may help you overcome the space-occupying lesion. So the lesion is like pinching off the arteries and increasing the pressure. And in order to overcome that, a massive increase in mean arterial pressure may help. And so that's the reason, I guess, in theory, why increased intracranial pressure will stimulate this. It's just this last-ditch attempt to keep your brain perfused. Okay? Sound good? All right, that is my last slide.